Hello, welcome to Unit 4, Lesson 6 with Professor Blackman. In this lesson, we're going to be talking about special factoring cases. We're going to look at ones where we have trinomial squares, which a lot of people will call perfect squares, the difference of squares, and sum and difference of cubes. Here I've also included a list of squares and cubes. Just seeing and recognizing these numbers will help speed up the process. So I've included the first 12. If you want to pause this video and put in your notes, I highly recommend it. But let's look at some examples. All right, so here we have trinomial squares. So a trinomial or a perfect square trinomial results in a binomial squared. So it's very easy to identify because the b squared is a square in the back end. You have a perfect square in the front, and then the middle is twice whatever that is. So you can see that this is 5 squared, which is 25, and negative 10 is a negative 2 times 5. And in front we have a 1, so multiplying by 1 doesn't change this at all. So in the result, this ends up being c minus 5 squared. Now, if you followed my previous videos, you will see that, with c squared minus 10, c plus 25, you need two numbers that multiply to give you 5 and add to give you negative 10. So that's c minus 5, c minus 5, which that's c minus 5 times itself. So that's c minus 5 squared. So you can do it with the rule or without the rule, but either way you'll get the same answer. All right, so here 4 is a perfect square of 2. In the middle is 2 times 2, which gives you the 4. So this becomes y plus 2 squared. And again, you can always check y times y squared, 2 times 2 gives you 4. 2 times y is 2y. 2 times y again is 2y, which gives you 4y in the middle. Let's look at some more examples. All right, so 1 is 1 squared, so this is, and the middle is 2 times 1, so this is x plus 1 squared. Here we have 64. 64 is 8 squared, and 16 in the middle is a negative 2 times 8. And again, we have a 1, so that doesn't really change any of the coefficients. So this is y minus 8 squared. All right, let's look at some more. All right, so here we have difference of squares. And so the difference of squares is a squared minus b squared. We'll give you a plus b, a minus b. So you can quickly identify that they are squares. So you have c squared and 25, which is c squared minus 5 squared. And we know its difference, which is the end result of subtraction. So this becomes c minus 5, c plus 5. And it doesn't matter if you write like that or if you write like that, because both ways are the same, because 3 times 4 is the same as 4 times 3. We know that in mathematics. All right, now, if you didn't want to learn the rule from my previous videos, this would be written out like so, where it's c squared plus 0c minus 25. So what are two numbers that multiply to give you negative 25 and add to give you 0? Well, that would be c plus 5 and c minus 5. Because c times c is c squared, 5 times negative 5 is negative 25. 5 minus 5 gives you 0 in the middle, which we typically would not write. It would just be written like c squared minus 25. But there's that understood 0 times c in the middle. All right, difference of squares here. 49 is 7 squared, and that is y squared. So this is y minus 7, y plus 7 when it is factored using the rule. All right, let's look at some more examples. Okay, so here now we get a little bit, we have some numbers out in front, but we can quickly identify that as 6x squared minus 7 squared. So once we have identified what makes the squares, then we can just put that in as 6x minus 7, 6x plus 7. All right, so let's look at this one. Well, we have 20, but 20 is not a perfect square, and neither is 245. But if you notice, they are both multiples of 5. So whenever you have a GCF, make sure we always factor that GCF out. And so we factor out a 5. Now we get 4a squared, which is a perfect square. And then negative 245, when you pull out a 5, gives you negative 49. So when we look at that, well, that's 2a squared minus 7 squared. And so now we can leave that 5 out in front and then factor into our two binomials, which is 2a minus 7 and 2a plus 7. All right, let's look at some more examples. All right, difference of squares. Well, if we look here, that is not a difference. Whenever you have this problem, you will put prime or not factorable. This is a sum of squares, which there is no rule. This cannot factor any further than it is now. Okay, over here we have 7x squared minus 10y squared. So quickly identify what your squares are, and then we can write that as 7x, because there's no middle term, minus 10y times 7x plus 10y. And so that one's factored. All right, now we have sum or difference of cubes. Now, one of the rules that I have always learned as an acronym is SOAP, same sign, opposite sign, always positive. And so that's just a quick way that I have learned as a trick to remember what signs they are. So since this is a positive, I know that it will be same sign, opposite sign, always positive. And now I can apply the rule. I will say this is one rule that you have to learn. You can't factor this without actually applying the rule that's given. So we can quickly identify that this is z to the third plus 3 to the third. And so then we just need to say that, well, a, wherever you see an a is now a z. So this is z. This is a squared, so this is z squared. And that's all we have for just our a's. Now we can do our b's. Well, b is 3, so this is 3. And this is 3 squared, which is 9. And then our middle is a times b, which is 3 times z, so 3z. And that's how we factor the sum of cubes. Be careful you don't confuse this with the perfect square, because the perfect square has a 2ab in the middle. This just has an ab in the middle. And we can always check it. So if I did check this one, I'll go ahead and rewrite it. Z plus 3, z squared minus 3z plus 9. And that gives me z to the third minus 3z squared plus 9z plus 3z squared minus 9z plus 27. As you see, those cancel, and you're left with z to the third plus 27. So again, remember, any factoring can always be checked by multiplication. All right, so now we have difference of cubes. And so I'm going to quickly write out my signs first. Same sign, opposite sign, always positive. And we can identify that our a is y cubed minus our b is 1 cubed. So that's y and 1, y squared and 1 squared. And then your middle is a times b. So 1 times y is y. All right, let's look at some more examples. All right, so here we have 2 cubed minus 5b cubed. So go ahead and write out same sign, opposite sign, always positive. All right, so first term, 2. First term squared, 4. First term, 5b, or last term is 5b. Last term squared, 25b squared. And remember, this middle is first term times last term. 2 times 5b, 10b. All right, so here when we look at this one, it is 4a cubed plus 1 cubed. And so when we write out our factors, we have same sign, opposite sign, always positive. I'm going to put 4a here. And 4a squared, which is 16a squared. And then last term squared. 1 squared is 1. And then your middle is your first term times your last term, which is 4a. 1 times 4a is 4a. That is all I have for you today. Happy studying.